Mobility is an essential part of our modern society. It enables us to transport people and goods, connect cities and countries, and promotes economic exchange as well as social interaction. Today's standard of living would be virtually inconceivable without the permanent development of transport. Tires made of rubber play a very important role in this. They contribute a lot to the performance and safety of road vehicles, and they provide greater comfort. Without tires, mobility could not have developed to the level we are using today. About 180 years ago, Charles Goodyear discovered vulcanization. Today, the tire industry is a major branch of industry. The world market for vehicle tires is currently estimated at way above 100 billion euros annually, with a rising trend. At the same time, aspects like sustainability and circular economy keep growing in importance for modern mobility. We know that the industry is aiming at more sustainability, from raw materials to production, right down to utilization and resource recovery. To this end, leading tire manufacturers have already launched projects and subscribed to ambitious voluntary commitments. Many initiatives have been launched for an all-out sustainable production. The scale we are talking about here is enormous. Globally, several thousand new tires are produced every minute, and they all need to be recycled again at some point. At present, only a small share of about 1% is used for the production of new tires. About 45% goes into the manufacture of other rubber products and rubber sheets for playgrounds. About 1% is turned into pyrolysis oil, which can be used for other chemical products. And the major share, 53%, goes back into the generation of energy. If new alternatives can be found and the recycling paths can be improved, this would mean great progress for a global product. At present, waste tires are for the most part recycled mechanically. This means that rubber is granulated and ground to create powdered rubber. It is used for the manufacture of rather simple rubber products like running tracks or rubber mats that serve as protection for playgrounds. And there is a technical background to this. The problem is that a large part of the recovered powder does so far not match the quality of produced new rubber. The recycled rubber cannot be blended well with the produced new rubber. So far, the technical limit is already reached at a small share of approximately 5%. This is why it can hardly be used for tires. If the tire compound contains more than just a few percent of powdered rubber, the effect makes itself felt quickly in the mechanical properties such as tensile strength and elongation at break. This results in poorer performance and detracts from the safety of the tire under high stress, and this is clearly unacceptable given high quality and safety standards. You see that first steps have indeed been taken already to use recycled rubber for the production of tires. However, the methods currently used drastically limit the possibilities to recover more useful recycling rubber for the manufacture of tires. This is why we are working on an innovative process for the recycling of tire rubber. The aim is to multiply the share of recycled rubber material in new tires compared with present solutions, while at the same time maintaining the high performance and safety standards of a tire. In order to understand our new approach, we first have to take a brief look at what tires are made of. A modern tire consists of many materials, such as natural and synthetic rubber, steel, textiles, and other chemical additives. Here you see an example of an average composition of a car tire. All this taken together turns tires into modern high-tech products. All the components are carefully tailored to each other to meet the requirements in terms of rolling resistance, abrasion resistance, and wet grip. Rubber, therefore, has a key role to play when it comes to the performance of tires. Rubber is produced by vulcanization. The process with pressure and heat combines raw rubber and many other components so as to create rubber. Sulfur has a key function in this. In the compound, it forms a robust three-dimensional network of sulfur compounds and carbon chains. This cross-linking network provides the rubber with its elastic properties and makes it resistant to abrasion and aging. However, this stable cross-linking also restricts the recycling potential. This is because it is technically difficult to precisely break up again the compounds which were established by vulcanization before. This is where we came in. We wanted to find out how this cross-linked network can be broken up again so as to improve the potential for recycling. Here it is important to break up especially the sulfur compounds as precisely as possible and to leave the long carbon chains in the rubber as intact as possible. This process is called devulcanization and typically takes place in a special machine. It absorbs continuously powdered rubber from waste tires, processes and molds it strongly at high temperature. In this way, part of the chemical bonds in the waste tire rubber can be broken up already. However, this classical approach is not very precise. It does not make any distinction when breaking up the chemical bonds. That is to say, it does not only break up the sulfur compounds as desired, but also cuts up the long carbon chains in one go. However, long carbon chains are important for the quality of the devulcanized rubber. If too many carbon compounds have been broken up, the quality of the material is reduced, which restricts the potential to use it in new car tires. Evonik has found out that specific chemicals, vinyl silanes, can help preserve long carbon chains. Here in the tire rubber, silanes make sure that under predefined conditions, sulfur compounds are opened up more specifically and all carbon chains are preserved. This has an impact on the result of the recycling process. It has already been demonstrated on a laboratory scale that the recycling material recovered in this way contains much more well-preserved carbon chains than previously used solutions. And this makes it possible to use more recycled material in new tires. Now it is also better suited for the production of new tires. Tests have shown that it can be well incorporated into the materials mix of new tires and be vulcanized again. One strong point of the new approach, the silane can or could be easily used on existing plants to improve the process. This would make it possible without any major additional expenses to achieve much better recycling results of a high quality. Building on this research and development success, Evonik is currently developing a system of devulcanization aids. On a laboratory scale and in cooperation with universities, Evonik has already approximately quadrupled the share of recycled rubber compared with the existing solutions. Trade associations of the tire recycling industry still regard an addition of approximately 5% of average waste tire material as an upper limit today. According to first research results, the rubber devulcanized by our method has a high quality. Many measured values are comparable with those of new material. Accordingly, the recycled material can also be used in the manufacture of new tires. Can the new method be expected to provide high-grade material also on a large scale? This would be a technical breakthrough. Much more recycled rubber could then be used for the production of new car tires than before. And it would even be a success that could be achieved without detracting at all from the safety and performance characteristics of new tires. Following the successful laboratory experiments, Evonik now intends to successively scale up the process and to take further steps towards practical day-to-day applications. Corresponding tests and trials are to provide additional insights. The aim is a better recycling solution which our customers can use also in industrial production. Should this be successful too, our innovation could overcome narrow old limits in the recycling of tires. Once successfully implemented in industry, the new process could make a contribution to more sustainability and circular economy in the mobility sector. More recycled and high-quality rubber in tires would reduce environmental pollution and conserve resources. With the recycling, Evonik also comes full circle. Our products have made green tires possible for years. These are car tires which cut fuel consumption by up to 8% compared with conventional tires. So our innovative silica silane system has revolutionized the production of car tires. So we have already been providing solutions for better production and use of car tires. Now we are also committing ourselves with the recycling of waste tires to a better innovative solution. Evonik itself does not produce or recycle any tires. We are committed to specialty chemicals. We provide knowledge, expertise and specific know-how from the chemical industry to make better products and processes available in many industries. We already manufacture a range of products for the tire industry. We will continue down this path by way of research, innovation and development. Climate protection and sustainability are global concerns. The EU, for instance, intends to become carbon neutral by 2050. Renewable raw materials, circular economy and sustainability are issues globally. This requires compelling technical, economic and ecological solutions in many fields. Evonik intends to develop a contribution to this with the new devulcanization method. It is about a sophisticated method meeting high technical requirements and quality standards in tire production. Raw material cycles and economic efficiency are no contradiction. Our efforts are aimed at recovering rubber by way of competitive recycling. The results speak for themselves.